We often wonder, why do we like the foods that we like? Why do certain foods taste good and other foods taste bad? What are the diets that we're adapted to, and what is the evidence of what our ancestors millions of years ago ate, and how did that diet change? We had several members of our team focused on trying to understand the origin of human diet. Dr. David Braun was researching the stone tools that were being used to cut meat off the bone. Dave Patterson was focused on looking at the kind of chemicals that get incorporated into teeth that tell you about the food that they ate. Literally, your teeth are what you eat. Dr. Neil Roach was looking at the evolution of throwing, and that was a very important change in anatomy that led to our ability to hunt. We as anthropologists, we study that question. What did we evolve to eat? And we have evidence that our ancestors preferred rich, fatty foods. And it's because they were really rare in the environment. So you had to like them enough to be motivated to work extra hard to get these really rich foods.
So this is a piece of a skull of a catfish, and these pieces of the skull of the catfish are the bones that we find marks that we think are butchery marks that reflects humans accessing these fish as part of their sort of versatile diet beginning at 1.95 million years ago. And they would have accessed them with these sharp-edged pieces of stone. So you can see, although it just looks like a piece of stone, it's got sharp edges along the outside, and it also has the place where humans struck it to chip off these sharp edges.
One of the main ways that we understand the way that fossil organisms sort of utilize the landscape is stable isotopes. Because as organisms walk around and sort of do their daily activities and eat particular plant items or drink particular water sources, those isotopes are incorporated into their teeth. This is important for understanding paleoecology because we can find these teeth on the landscape and then we can sample them, sample their enamel for those particular stable isotopes. Once we take those teeth, we can drill their enamel, sort of extract those isotopes, and understand the types of vegetation that particular organisms are eating and the types of water sources that they're utilizing. When we do this for a whole assemblage, we can get a better idea of the particular sort of relative proportions of particular vegetation on the landscape. Now, this is important for paleontologists who are just interested in fauna. But for paleoanthropologists, it's also important because you can do this with hominins as well. And when we're here at Koobi Fora, we're looking at a pretty good diversity of hominid taxa. And so from that, we can then use that to sort of formulate hypotheses about particular hominid taxa and how they utilize the landscape.
The ability to throw with a tremendous velocity and tremendous accuracy could have been incredibly important in our evolutionary past. Throwing seems to have arisen around 2 million years ago. At around that same time, we see the first major intensification of hunting. So we start to see good evidence in terms of cut-marked bone and an increased prevalence of hominins using animals in the landscape and eating meat. These bits of evidence are suggestive of the fact that hunting seems to at least have intensified around this time.
So with evidence like this, we're coming to learn that there is no one Paleolithic diet. That in fact, we're adapted to eating a wide variety of foods. And our ancestors had the ability to make tools and to access all kinds of foods. And those tools allowed them to conquer new habitats with new kinds of foods and even increase the diversity of their diets. Now today, with all the technology that we have, we've been able to make our food so much more accessible that there's a temptation to go after the food that we crave. But what we need to do is make sure that we keep that wide variety in our diet, just as our ancestors did.